Hello everybody, welcome to my YouTube channel Easy Mathematics. Now it is the time for Cauchy mean value theorem. That is one more extension from the Lagrange mean value theorem you see. At first let us discuss the statement. After that I shall give you a real-time example so that we can understand the theorem much better. So statement for the theorem is, let f and g, here two functions are there, be two functions defined on the closed interval ab such that both the functions are continuous on the closed interval ab and both the functions are differentiable on the open interval ab. One more condition is added here, that the derivative of g dash x not equals to 0 for any x within the given interval. If all those conditions will fulfilling, then there definitely exists at least one value c lies in between ab such that f of p minus f of a divided by gb minus ga is equals to f dash c by g dash c. So probably its geometrical interpretation is not found in any book. But what happens here? Just observe the formula very carefully. This one is the distance. Both are the distance value. So this is the distance in between the interval ab for the first function and this is the distance for the second function. And here it is the ratio. This one is what? The derivative of the function, first function, and this is the derivative of the second function and this is the ratio. If we apply the physics here, then we will say that this is nothing but the speed value, speed formula, is it not? Speed should be represented by the derivative of the given function. So the distance ratio is equals to the speed ratio. That means distance covered by the two functions within the given interval should be equal or equivalent. That means their ratio should be equal by the ratio of their speed, that we can see. For example, we can say that suppose two bikes are there and they have started their journey in the same time, and after half an hour, suppose after half an hour they just cover the double, that means one bike covered the double distance of another. That means suppose the first bike if covered the 10 kilometer, then the second bike covers the distance 20 kilometer within the same stipulated time. Then can we have any idea regarding their speeds? Probably, perhaps we can say the speed of one bike is exactly double of the second bike. But in the practical situation that will not happen. Why? Because it is not possible in a live road there one bike started his journey with a uniform speed. It sometimes goes down, sometimes goes up. So but by this Cauchy's mean value theorem, if we apply, then from there we can say that in between the entire journey, the one bike definitely acquires the double speed of by compared to the another one. Otherwise, it is not possible to cover the exactly double distance within the same stipulated time. So that is one thing you can just imagine about the Cauchy's mean value theorem. I just try to give you a geometrical format. So geometrically we can represent this Cauchy mean value theorem this way. Here the two functions are defined, fx and gx, and accordingly the tangent we will find out at a particular c value where they have the same ratio as their distance ratio is. So this is our Cauchy mean value theorem. Now let us do some application, that means few problems on the Cauchy mean value theorem so that we can understand the application of this theorem much better. So first example, verify Cauchy's mean value theorem for the following pair. So what is the given functions? Fx is equals to cos x and the sin x within the range minus pi by 2 to 0. First of all, these two are very known functions to us. So let us take the curve of this one. So this is our sine curve and this is our cos curve. So within the range 0 to pi by 2. So actual feasible curves are this one and this one. Is it now? So now what we will say, that both the functions as they are the trigonometric functions, so they are continuous and the differentiable for all r values whatever be the real value, in all the real values the functions are continuous as well as differentiable. Now the derivative of the first function, is minus of sin x, and the second function is cos x. And definitely g dash x not equals to 0 within this range. 0 is not included, okay, minus pi by 2 is also not included. So now all the conditions for the Cauchy mean value theorem satisfied over here. So definitely we will find out our C lies in between these two, so that we will fulfilling this formula. So if we now substitute all those values, then we will find out that the C value is minus pi by 4. So this value lies definitely in between these two. Hence the Cauchy mean value theorem verified, and the C value is this one. One more problem is given as the function fx is differentiable on the interval a comma b, where a into b is greater than 0 always. Then so that the following inequality holds for the function. So this one, this equality, not inequality, this one 1 by a minus b, then it is the determinant of ab and fa fb is equals to fc minus c into f dash c. So now how to prove this one? So first of all, it is given that a into b is greater than 0. What does it mean? That a must not be 0 and b must not be 0. Therefore within this range ab, this does not contain the point x is equals to 0. Now let us consider two functions. One is fx, which is, let us say, fx, small fx, this is by x, and gx is another function, let it be 1 by x. So that we can find out the derivative of this function. It should be, here it is the u by v format, so it is x into f dash x minus fx by x square, and its derivative is simple, it is minus of 1 upon x square. Now if we apply the Cauchy mean value theorem here, then we can say the above two functions within this range, we will find out a value c lies in between a and b, this c value. Then in the Lagrange Cauchy mean value theorem, we will find out fb minus fa, this is capital, and gb minus ga is equals to f dash c by g dash c. So if you substitute all those values and simplify, then we will find out it is as a fb minus b fa by a minus b is equals to fc minus c into f dash c. So that part will be matching with the given condition, and this one for we can write 1 divided by a minus b outside. So this portion is nothing but the determinant of this one. Just look at this one. If we multiply these two minus these two, then we will get this one. So we can write this one in the form of this one, and which is our required inequality which we are supposed to prove, and hence the proof. Here is one more example, that is so that at x not equals to 0, the following inequality holds. The inequality is what? That is 1 minus x square by 2 less than cos x. So what to do? Again here we construct the two functions. Let one function fx is 1 minus cos x and another one is gx is equals to x square by 2. How we will take this? We just take here 1 minus cos x, and this is this side, so x square by 2. So we take this is fx, this is gx. Now very simple, if we apply the simple Cauchy mean value theorem and substitute according to this all values and simplify, then what we will find out from here? Just observe here, this is the formula, and if you substitute and simplify, then we will find out that portion. Now what happens? This expression particularly always less than 1 for c not equals to 0. If c not equals to 0, we know this expression is always less than 1. Now what happens here? So as this one is less than 1, we can say this entire thing is also less than 1. So we can write so. So that means we will find out from here this portion is less than 1. So 1 minus cos x is less than x square by 2. So that will imply 1 minus x square by 2 less than cos x. Hence the inequality holds. So now it is your time. So it is do by yourself question. The first question is, in Cauchy mean value theorem, if fx is equals to e to the power x and gx is equals to e to the power minus x, then so that theta is independent of both x and h, and it is equals to half. This is your first question. And the second question is verify Cauchy mean value theorem for the following functions, and the function is given fx is equals to root x and gx is equals to 1 by root x within the interval -1 comma 2. So verify Cauchy mean value theorem for these two functions and write your comment in the comment box.